Good morning, everybody. Thank you for attending this, taking time out to attend this presentation. What you're going to see here this morning is a presentation I did back in Denver on the 26th of August. So this is the presentation, like I said, which was done at Share. Just an abstract of what I'm going to cover today. We know that APPN and SNA is alive and well out there in the marketplace. And the success of the internet has actually forced companies to use TCP/IP support for many of the SNA legacy applications. So inside of this particular presentation, I'm going to cover what is Enterprise Extender, some of the pitfalls to look out for, and the challenges of migrating a large SNA network onto Enterprise Extender. Here's an interesting fact I pulled off the internet that I thought I would share with you. As of mid-2009, there were 7,000 plus larger 3745 models out in production status. That has gone down. However, you'll see that the figures have gone down because of IBM have come up with a solution called CCL, which allows customers to migrate off the 3745 onto Communications Controller for Linux, CCL. And that is, a lot of customers have migrated onto that, but we find that going onto Enterprise Extender is probably more of a seamless migration, migrating your SNA protocols onto an IP backbone. Okay, the agenda for today's presentation, I'm going to give a brief introduction, Enterprise Extender overview. I'm going to give you a bit of my EE migration experience where I worked, some of the pitfalls to look out for, and lastly, we'll field some questions. My name is Colin van der Ross. I'm a senior systems engineer and I work for a company called Software Diversified Services. We're based in Minneapolis, Minnesota. And we're a software company developing networking products for mainframe systems. Okay, a brief overview of what Enterprise Extender is all about. Essentially, SNA transport over a native IP network with no changes required to the SNA applications. Now that is very key. Most customers, when you talk about migrating your network onto a different platform or backbone, people are always considering what changes is there to be made to the applications. When you're converting your SNA network onto Enterprise Extender, no changes required to your SNA application. So that is very, very key from a migration point of view. The SNA application connectivity, it uses an IP backbone that supports the preservation of SNA transmission priority. So what I'm saying there is, in SNA you have different priorities. You have transmission priority 0, transmission priority 1 and 2. You can still preserve all that priority, and you can still provide customers with the exact same response times they used to experience on an SNA network. And lastly, end-to-end failure protection and data prioritization. Depending on how you implement Enterprise Extender using HPR, if there's a failure inside of your IP backbone, your users out there won't even know there's a failure, and automatically they will just get rerouted on the next available path inside of your IP backbone. So that is a very high-level overview of what Enterprise Extender is all about. Here you can see your SNA network connected to a 3745 or an NTP as we know it, and those are your mainframes. There's your IP backbone. You take all that equipment, that's all the lines that were on the 3745, migrate them onto your IP backbone, and you have your SNA clients running over your IP backbone, and it's, like I said earlier, seamless to the end user out there. No changes on your application required, and people just carry on working as normal. Just to expand some more, continuing on the Enterprise Extender overview. So Enterprise Extender is HPR routing over an IP network, as we said. To the IP network, Enterprise Extender appears as a UDP application. To the APPN network, it just looks like another HPR link. There's different implementations of Enterprise Extender. I just thought I'd mention this because this is the experience that I had when we migrated Enterprise Extender or we rolled out Enterprise Extender on our network. Something called Dependent LU Access, or DLUR, DLUS. That stands for Dependent LU Requester and Dependent LU Server. So what that does, it's sub-area SNA traffic, or traffic that's running on an NCP and is based on normal APPN, DLUR, DLUS functions. The SNA traffic is sent as a UDP datagram over the IP network, and each endpoint using 5 UDP port numbers. And these are the port numbers that IBM have reserved for the use of Enterprise Extender. And then Enterprise Extender platforms include ZOS, ComServer Linux, ComServer AIX, Windows, and something called Cisco SNA switch, which is code that runs on a router, and that was the implementation that I had experience on. Some things just to bear in mind as well: Enterprise Extender traffic can be secured using IPsec, not with SSL TLS, because that's for TCP only. And in environments where you have SNI connectivity, you can use something called extended border node to achieve connectivity to your business partners. Here's a little diagram of UDP ports. Okay, as I was talking about the UDP, this is an example of UDP ports. In this illustration, this is taken from the product that SDS markets called VIP, one of the leading monitors, network monitors, that can tell you everything you need to know about your IP network on ZOS platforms. And here you can see this is a fine illustration of UDP ports. Gives you great information on bytes sent, bytes, outgoing bytes, inbound datagrams, and outbound diagrams. Just bear in mind, this is just one of many screens where this particular product can give you great visibility into your Enterprise Extender and HPR connections. For an Enterprise Extender network, now what I'm trying to show you here in this illustration is all the different port numbers. As I mentioned, ports 12,000 to 12,004 is reserved for Enterprise Extender UDP connections. There you can see the UDP port numbers, a little schematic, little performance information on each port. 12,000 is a control port, but we will cover that in more depth later in this presentation. Another little diagram on your HPR connections, all good information. Something that is very pertinent when you're running an Enterprise Extender network is ARP pacing. There you can see there's some congestion here. NLP is queued on this particular connection. And something that is always important to Enterprise Extender users is path switches. And we will cover that later on in our presentation as well. Okay, so we're continuing with the Enterprise Extender overview. Just talking about DLUR, DLUS. The DLUR function can reside on any of IBM's distributed servers, as I said earlier. DLURs can be located in remote sites. So in this diagram here, what I've illustrated here, there's your VTAM, your SSCP, and your DLUS. You can have your DLUS function residing over there. There's your APPN network node. Or you can have it down on a router function where they're using SNA switching. So here's where your DLUR function would reside. And there's all your downstream or your dependent LUs as we know them. Something to bear in mind, something to remember about when you're implementing an Enterprise Extender network. Try and limit the amount of network nodes inside of your Enterprise Extender network. By that I mean, the fewer network nodes you have out in your network, the fewer topology database updates you're going to have. So consequently, if you have hundreds of network nodes out there and anything fails inside of your network, all these topology database updates are going to be sent up to your owning network node. And the recommendation from IBM is have as few network nodes possible in your Enterprise Extender network. You'll see when I talk about my actual implementation how many network nodes we had in our configuration. And then just to elaborate again, vendors that do support DLUR, DLUS function is the Cisco SNA switch code that runs on a router. This is something unique, and I think and most people, if you are implementing Enterprise Extender, you need to look at implementing something called a connection network. Now you may ask me, what is a connection network? A connection network is an APPN technology that reduces the amount of predefining APPN links between nodes that are shared or connected to a shared access transport facility. Okay, let me try and put that in English for you. Here we've got 4 hosts, and here we've got all these connections out here that's now wanting to talk to all these different applications residing on these mainframes. If I didn't have this connection network, or VRN as we know it, what would actually happen is, let's say for example, that guy over there, Enterprise Extender Node 1, wants to log on to an application on ZOS Node 1, and my Enterprise Extender configuration was active on ZOS Node 4. What would actually happen is, he would go all the way from there into the IP backbone, into ZOS Node 4, and then from ZOS Node 4, get routed across to the application that he wants to talk to on ZOS Node 1. When you implement a VRN or a shared access transport facility, what that actually allows you to do is, when it gets to the IP backbone and Enterprise Extender now sees, there's a VRN set up for this particular connection, what he does, he takes that connection and routes it straight off to where it needs to be. So what you can see, what it actually does for you here is, VTAM no longer acts as a router. He'll get to the VRN and service the request, send it off to the application that he needs to talk to. So this is something that's very key. You might not want to do this initially when you roll out to your Enterprise Extender network, but as you get more and more clients on, this is something to bear in mind. You have to do this. It's going to cut down on the amount of traffic that your interchange node or your network, your CMC, or the guy that's performing all your Enterprise Extender configurations, it's going to cut down the amount of traffic or the routing that he has to do. Okay, it's just something that you'll find a lot of people use, because SNA, like I said to you in the abstract, is still alive and well out there. A lot of SNI stands for System Network Interconnection. So there's guys out there on an NCP that's talking to corporate customers out in different parts of the world or in the country. The option to actually migrate SNI, you can move it onto something called Extended Border Node, which allows you to still use the same method of transport across your IP backbone, and then you can get rid of your NCP. Okay, just a few points on planning. Enterprise Extender relies on your IP network strategy and integrity. An effective IP network design is essential to ensure a successful Enterprise Extender implementation. By that I mean, if you have an IP network that doesn't have resilience or redundancy, because the SNA network is actually traveling across your IP network, you need to ensure that your IP network has full redundancy and failover capabilities. And then lastly, the robustness of Enterprise Extender depends on the stability of the IP network. Like I said, a stable IP network ensures the availability of SNA applications. So bottom line is, you got an IP network that is stable and you have sufficient bandwidth on there, your SNA applications are going to be guaranteed a good response time, and you won't have a lot of path switching. Some more points to take note before you roll out your Enterprise Extender network, or you plan to do that. Some more stuff to consider. The dynamic routing update protocols being used, OSPF, RIP version 2, and EIGRP. That is something that's proprietary from Cisco. In my experience, we use OSPF, or OMP route as IBM calls it. The use of the private network in contrast to a public network. So in your environment, are you using a public network or are you using a private network? The type of network interface being used, is it QDIO? As well as the MTU size, the maximum transmission unit size. The IP security mechanisms, NAT, network address translation, IPsec, firewalls, all things to bear in mind when you're setting up your Enterprise Extender network. And lastly, the quality of service for the WAN. So do you have your SNA traffic for your interactive traffic? Have you got it running in gold class? Have you got it platinum? You need to decide and plan all this up front before you actually continue with your enterprise extender rollout. Few more considerations. Do you want to use host names or IP addresses for your IP configuration? Do you maintain a DNS to resolve host names? Decide whether you're going to use enterprise extended connection networks, which I recommend, and determine whether NAT is going to be used. Let's talk a bit about the design. Proper design is critical for the enterprise extended network. Spread your enterprise extended connections for a balanced workload and avoid sending all EE connections through the primary host. We spoke about that earlier, do you remember, in the connection network? Use direct enterprise extended connections to endpoints. That is self-explanatory. You don't want it going via different hosts, where if you can send the connection straight to the endpoint, do that. Consider an enterprise extended connection network, which will simplify definitions. And lastly, avoid using VTAM as a router. Definition types. I just put this table here just to kind of give you a feel for the different types of implementations. Some people might define or decide to define all their definitions statically, where others might decide to go with the dynamic route. So if you code dyne PU equals no, this is one of the startup options you have in VTAM. That essentially tells VTAM you're not allowed to allocate dynamic PUs on the fly. If you say dyne PU equals yes, the opposite is in effect. So what does it do for you? This is more secure because you're going to control all the PUs that's coming into your network. Whereas that one there, you might have somebody that comes in and you're not aware of it, or you're not too sure who the guy is. The ability to manage specific connections with user-defined names. So you can say anybody that's coming in from this particular environment, this is the naming prefix he must use. Whereas there, IBM come up with their naming standards, and you'll find, for example, your HPR connections is going to start with the prefix CNR, and your Ps will start with the prefix XX. So that's something that you need to bear in mind. You might not be in control of those assigned names. This is obviously more flexible, different characteristics for different connections. This is less flexible. Here you can control the transmission group number that you want to assign for 4 connections. Over here you don't have any control over that. IBM assign a transmission group number 21 for default APPN connections or enterprise extended connections, and more resources or definitions to maintain. So you're going to obviously have your network systems programmer coding late into the night when he wants to roll out these enterprise extended connections, whereas here you just fire it up, and as the guys come in, so those names will get assigned to him. Some common problems to look out for. We mentioned this earlier, firewall issues. Those are the standard ports that we use, 12,000 to 12,004. You must allow UDP ports open on the firewall for enterprise extended to work. You'll see there's an illustration later on where I do a trace route and these ports are not open. Consequently, those enterprise extended connections fail. Path switch retry, the default is off. This will enable HPR pipes to switch automatically. So you need to consider whether you want to have this option on or not. What this does for you is you can actually specify the time that you want, and if that time does expire, automatically he'll try and look for a better route. You need to consider whether you want it on, whether you want it off. Configure the APPN link characteristics. New transmission group profiles for enterprise extender provided with VTAM customization. There's a sample that IBM give you called the IBM TGPS. You copy that into your VTAM list. You then can configure this, and you can say exactly which connections you want to actually. So for example, connections coming from New York, you can say this is the transmission group profile you want to use. Connections coming from a different part of the area, you can actually control that. So that gives you that specific control. So here's an example of a trace route where I done, and here you can see the enterprise extender partner responded successfully. Some good meaningful information on here. Time in milliseconds between hops, between each path on this enterprise extender connection. And here you can see this particular trace route works successfully. So in this example, firewall, UDP ports were open in the firewall, and there's no problem here. Have a look at this one over here. It got to a certain point on hop number 4, and consequently, that's probably where the firewall was, and no probes were allowed through. So be aware of this. Make sure that those particular ports are open, and this will allow you your enterprise extended connections to succeed. Some more common problems. DW Act. That's something you need to remember as well when you're firing up your enterprise extended connection. Do you want it on? Something to remember as well, don't have it on both sides. So if you have enterprise extended connections on 2 LPARs and they both fire up at the same time, if you have that parameter specified on both of them, it'll cause a conflict. So you need to decide on which side you want to do it. The other option you have is the VeryNet dial command, which can also fire up those enterprise extended connections. If defining an enterprise connection over an IP network which uses NAT, define the VRN addressability using the hostname operand and do not use the IP address. I will cover this later in more depth in my presentation. Okay, so what I'm going to do now is I'm actually going to talk about my migration experience. Let me just give you a bit of background. I used to work for a large bank in South Africa. It was primarily a SNA network. We had 22 3745s. Very big network, over 80,000 devices in the network, running True Blue, IBM, NCP, SNA network. So what is our biggest problem? We had all these NCPs here, and I'm sure many of you can relate to this. When you had to run NCP gens, it wasn't as dynamic. We had this change control slot where once a month we were allowed to make changes. So let's say, for example, a branch came online for plus minus 2 or 3 weeks, depending on the time. The branch couldn't come online because we had these change control slots where we were allowed to make these changes. So as you can see, it wasn't good from a business point of view. If somebody comes online, the bank was in the game to make money. We need to be dynamic. So that is one of the problems we experience. And also, imagine trying to do NCP gens for 22 NCPs out there. It can be quite complex. Can be prone to errors and also very difficult to manage. So let me just give you a quick overview of what we had. We had the one data center, and we had a data center 2, which is essentially the backup. So if this particular data center failed, automatically we would switch to the data center which was located in a different location. We had all these links between the different centers. And as you can see, this was called an INN NCP, or intermediate network node, which then spoke to the intermediate network nodes on the other side. So here you can see he had a primary link over there, and then he had a backup link on the other side. So that was an SNI connection. But here you can see primary link and backup link. So if that failed, the traffic would go via the backup path, but there still would be interruption to your SNA connections. Now, this is the great part about Enterprise Extender. If you implement Enterprise Extender and you implement HPR in your backbone, and that link fails over there, because all this here is in an IP network, the user is not even aware of this. Automatically, his session will reroute around whatever path is available, and he'll just continue working. So he might experience a little bit of a delay in response time. When the HPR connection finds a better route, automatically all that session traffic will be routed and the guy will just continue working. We had more than 1,000 branches, and just to shock you, we still used OS2 operating system from IBM. In many ways, this made our migration process very easy, because what that actually done for us, OS2 was already set up for APPN. So all we needed to do was change a few key parameters inside of the network definition file, which essentially changed all these devices out there from network nodes to end nodes. Like I said to you, the fewer end nodes you have in your enterprise extended network, the better. We had APPN enabled in our data centers already, so it was enabled in all the LPARs there. Just to give you a bit of background as well, we looked at going a full APPN network using something called the IBM 950 component, or the MAE, but that failed horribly, and that's the reason why we looked at using Enterprise Extender. We had 2 interchange nodes, so one in each center. An interchange node is essentially a node that's allowed to operate both sub-area and APPN networking. And we had 10 migration data hosts, which then says they were data hosts, which allowed them to communicate using APPN. So that's a high-level view of what the bank's network looked like before we went enterprise extender. Look at that from the previous one. Let me just go back again for you. Look how cluttered that is. And let me just briefly take you through. Same data center 1, data center 2. Now we've got our IP backbone in between. We've got a layer 3 switch, which was where our OSA, one of our OSA connection, well, it was connected to the OSA. We had a Cisco 7500 router in each center running the Cisco SNA switching code. So there you can see data center 2, there's the layer 3 switch, and there's the Cisco 7500 routers running the SNA switching code. And there's exactly the same environment. There's our branch environment with the file server configured to be a end node. And all we had to do was configure him to be able to talk to his DLUS. So let me just talk you through the bullet points here. We replaced all the FEPs with 4 Cisco routers. We had OSPF in the data centers, in both data center 1 and data center 2. The branch servers were set as end nodes. We used OSA QDIO. Between LPARs, we use something called hypersockets. I'm sure many of you are familiar with that. That allows you gigabit connections between your LPARs. And we implemented connection networks to avoid VTAM being used as a router. These are some of the problems that we experienced during our migration process. When we initially rolled out the enterprise extender and the SNA switching code on the 75 routers like I explained in the previous slide, what actually happened was during busy times, the router actually reset. So that wasn't a good thing. Think of it on a Friday afternoon, people banking, people needing money for the weekend, and your ATMs are not available. Consequently, the management's first reaction was, back it out, this is not working for us. Go back to the NCPs, we know that works. Fortunately, there was a problem on the SNA switching code. Cisco gave us some patches, we applied that, and that was resolved. So that was one of the major problems we had, and it wasn't really related to enterprise extender, it was more code related on the router. We had some LE2 type devices that went into a pactal state, that's a pending active link state, when there was an outage on the IP network. The only way we could get around this particular problem was to reset the branch router or the enterprise extender router. It was more of an irritation than anything else, and we tried logging a problem with IBM for OS2, but because OS2 is not supported, we implemented automation procedures to circumvent this particular problem. Some more problems we experienced. We used to use a product called NDM, which just stands for Network Distribution Manager, where a specific team used to download all these configurations for the different banking branches out there, and they needed to know which independent LU they talk to, so we statically coded them. In the Enterprise Extender, you cannot statically code independent LUs or LUs with a local address of 0. Remove them from your switch major nodes. What will happen is when it comes up, it'll register itself with its network node server, and it'll look like a normal cross-domain resource. One of the things that caught us out wasn't really a big problem. Like I said to you, register with your network node, and that resolved our problem. We had to write a few automation procedures to monitor the state of the CP/CP sessions. So this is very critical. Your routers start CP/CP sessions to your mainframe. If that goes down, that affects all your dependent LUs that's hanging off your DLUR connections. There's a message that gets generated, an IST error message. We wrote automation, and the minute this message came up in the log, we would fire off these messages to our pages, to our cell phones, to emails, to the automation procedures inside of the network monitoring control center, and alert people, hey, there's a big problem, you need to follow up and see why the CP/CP session has gone down. So that's something you need to bear in mind. Does your monitoring product have that? This is something that is very key from a monitoring point of view. Like I said to you, with the Pactal problem we spoke about, we had to, on the weekends, we used to automatically, some weekends we had to recycle the owning or the network machine. This would cause some of those devices to go into that Pactal state. We had to write automation to get those devices in a ready state for users to be able to use on the Monday morning. We had a few agency issues. I'm not going to go into too much there. That was local to what the bank, how they implemented agencies there. Something that's very key, I'll cover this also later in my presentation. You have to monitor your VTM buffers and tune accordingly. So as you cut over onto Enterprise Extender, make sure that your buffers are not thrashing. You have sufficient buffer capacity. You have to keep an eye on this. So set some sort of a timer routine, check your buffers, and if they do go beyond a certain threshold, you have to take action. Something we had to do as well, now you have the help desk out there that we're used to using NCPs and that kind of thing. We had to educate them and show them the differences between monitoring an SNA NCP network and now monitoring an Enterprise Extender network. So that was a few things that we had to address. Get the user, the guys on the help desk, give a little training course for them, but that was also not a big showstopper. Okay, there's no such a thing as a free lunch. You're getting rid of your NCPs. Somewhere along the line, you're going to have to pay for that. So as you can imagine, we save a lot of money, but by getting rid of the NCP. So this is where we took a hit as such. VTM and TCP/IP, the average increase in CPU utilization increased by 6 to 8%. This was an average. It would spike occasionally depending on if there was outages on the network. We saw real storage increase also by an average of 5 to 6% on TCP/IP and VTM. So because that boundary function is no longer being performed by your NCP, this is where it takes place inside of VTM and TCP/IP, and that's where we saw the increase. So don't think you're going to get it for nothing. You have to pay for it somewhere. There's a significant cost savings. The hardware maintenance, software licensing, that was quite an exorbitant amount we used to pay on a quarterly basis. That no longer applied because we got rid of all that technology. Help desk and support training cost. There was no real changes from a monitoring and control point of view. So we didn't have this new technology out there that we had to send all our guys on training to be able to monitor this network. There's no application changes needed to implement Enterprise Extender. Like we said at the beginning of this presentation, from the applications point of view, it is seamless. And no great in-depth training required for network systems programmer on Enterprise Extender. If you know APPN and you know a bit of SNA, I'm sure most systems programmers will be able to implement Enterprise Extender in their environments. Some of the benefits, the network recovery is very easy. The backup DLS on standby and network definitions were active on the backup system. Now this was very great. Like I said to you earlier, on the weekends we have this primary network, and now they needed to shut down this data center and move it to another data center. All we would do is shut down VTM on this side. Automatically the ownership would take control on the backup network without you doing anything. So that's your primary and backup DLS as I'm alluding to there. This is really great. In the old SNA days, what you had to do, you had to have these fancy network routines to actually take ownership from one SSCP to another. Using Enterprise Extender, you code what your backup DLS is. Automatically, if your primary is not available, within a certain amount of time, you'll automatically switch to your backup. Network connections to data hosts remained up. So by that I mean, if you had an ATN that was talking to an application on a different host, automatically when that network went down, because of connection networks, that particular session wouldn't be lost. The only problem was if a new session request would come while this particular switch was taking place, that session wouldn't be serviced. Some more benefits, it can be a staged approach. We migrated 50 branches per night and then took a checkpoint and measurements. The recovery of Enterprise Extender routers took a couple of minutes as opposed to reloading an NCP, which we all know takes quite a bit of time. Complete redundancy as branches were configured with alternate peers. By that I mean, if the primary router wasn't available, we could configure the backup peer to the alternate router, and automatically you would then gain connectivity over there, more dynamic and flexible. And this is something that you need to bear in mind as well. Make sure the network monitor that you're using gives you great visibility into your enterprise extended and HPR network. So if there is problems, you need to be aware of it. If your monitor doesn't tell you about it, then you're going to be in serious problems. Okay, that kind of concludes my background. I'm just going to now cover a few key parameters or few key operands that you need to be aware of when implementing an enterprise extended network. What to look out for. And HPR timers, this is something that is very key, and this is something that you're going to have to find the right balance inside of your network. There's a few key parameters: the live time, the SRQ time, the retry, which you're going to have to tune, and like I said, find the right balance for your network. Something to remember from ZOS 1.9, the inactive logical data link control was enhanced to support unique inactive timer settings for each local IP address. So this is something that's new that's come along. You can enforce it depending on what IP address you use. So let's cover some of these parameters I just spoke about. Live time. What is live time all about? It controls how fast VTM will recognize the loss of a connectivity on a link to a remote enterprise extender node and enter path switch state for that HPR pipe. So if you set the time to if you set the time, let's say for example you set the time is too limited, that'll cause the switching to occur frequently. If you set it for an extended period of time, that might cause it to have the opposite effect, where a link has failed and he hasn't picked it up, it has failed. So consequently, all those users on that HPR pipe won't get switched to an alternate path because that particular time hasn't expired. Again, the IBM default is 10 seconds. We initially went out with 10 seconds, and that seemed to work for us. But then again, we had a fairly stable IP network. The EE node constantly sends LDLC test frames on idle links at regular intervals. So you need that's the liveness timer. If the remote side does not answer within that specific time, LDLC test frame is resent until the retry count is exceeded. So you'll see how this all hangs together in the next few slides. The remote side still does not respond. The link is considered dead and inop, and that particular path will then go down. So live time specifies how often the test frames are sent out. It works on port 12,000. So it'll send out these test frames all the time. Are you there? Are you there? If it doesn't get a response within that designated amount of time, that's when it'll enter into path switch. VTM can use incremental liveness timer to reduce the number of test frames sent into the network on idle connections. So you can specify an initial value and a maximum value. We just use an initial value. That worked for our particular implementation. Something to bear in mind, like I just said earlier, in large networks, the amount of UDP port on 12,000 can cause a higher overhead in the network and increase CPU consumption in both VTM and TCP/IP because packets flow 7 by 24 hours. So what am I saying there? Depending on what you send, those LDLC test frames are going to be sent all the time. And if you set the incorrect value, it could be a bit of an overhead because he has to send these frames out all the time and say, are you there? Are you there? Are you there? And if you set it too low, it can be an overhead on your system. So be aware of that as well. By specifying a maximum value, VTM will increase the intervals on idle connections and reduce the number of test frames. The downside that it will take longer to recognize an outage, which I just said. The above applies to idle connections. And when HPR traffic resumes over an enterprise extended connection, the current liveness window will reset to the initial setting. So the minute activity comes on, he'll reset his timer, and he then will continue monitoring that particular connection unless there's no connectivity or any traffic on that particular HPR path. Okay, here's just a table I thought I'd bring up just for your interest's sake, just to give you the different default. There you can see VTM, the default is 10 seconds. That's the SRQ timer, the retries, how long he's going to try and recover that particular connection, and the total time. Those are the other platforms that's supported, which I'm sure you can follow that up if that's the implementation that you're going to pursue. Yes, a few things to remember about SRQ time and SRQ retry. They do not have any influence on the SRQ timers on HPR pipes. They are maintained by the ARB algorithm or the adaptive rate-based algorithm and cannot be configured. SRQ time, the default is 15. It specifies the EE logical link, control short request timer interval in seconds. So that's the default. The default for SRQ retry is 3. Specifies the number of times the short request timer is tried before the port goes down. Disconnect equals no. That's the default. So when VTEM should end its SSCP LU session or SSCP PU session, recommended to be no for predefined enterprise extended connections. For enterprise extended connections or VRN dynamic connections, consider coding time-tap equals VN. Now that you do on your XCA major node or a delay value that is greater than 60 seconds. CICS LU 6.2 users, take note of this. This is a parameter that you need to code this particular parameter, because every time it prevents sessions terminating at the end of every transaction. So if you are CICS users and you're using LU 6.2, remember that as well as part of your implementation. Dyne PU equals yes, that's a default. We spoke about that as well. Can be changed using Dyne tap on the E model PU. That's again on your enterprise extender. So if you want to say Dyne PU equals no for your VTEM start option, but you want to code it on your Dyne tap equals E on your model PU, you can override it over there. Dyne tap RTP also on your model, you can code it with disconnect equals no. That it says keep all the RTP pipes active even with no sessions active. If you want to do it that particular way, bear in mind these CPU implications. Take down activities and promotes consistent latency and response times. The enterprise extender liveness, that's the default as well. IBM recommend you set it to yes. And then the RTP layer is responsible for driving status requests frequently to keep disconnect timer from expiring. So the RTP endpoint will drop the connection if its last session goes away and no new sessions is queued for a period of 10 seconds. So that's how the RTP, or that's what the RTP layer is responsible for. I spoke about this as well, T1 buff and T2 buff. These are the new buffers that came along with VTEM. I'm not too sure what the version of VTEM that it came along, but essentially got to do with QDIO and iQDIO. The default numbers of buffers is inadequate. You have to tune that for serious users of enterprise extender. Like I said, monitor these buffers and take the appropriate action if you do find they're expanding. Exploit the group-based enhancements on version 1.9, so you can exploit it on your XCA. Recommendation, leave iPort operand on 12,000, because if you do change it, that means you need to go out there and change all those particular platforms that you're talking to. The MTU size, I'm just going to glance over this as well. This is something to ensure optimal performance. The TCP/IP MTU size should be greater than or equal to the RTP network layer packet size. I find out there most people adhere to the common Ethernet MTU size, which is 1492. If you're using that, that should suffice. VTEM queries TCP/IP for its MTU size when establishing an RTP connection or CPCP session or LU session. Here's a quick table on how VTEM does its calculation for MTU size. So if the node is the origin of the RTP connection, VTEM will then set the maximum packet size equal to the less of the MTU size or the VTEM maximum data size. If the node is an intermediate node or destination node, he sets the maximum packet size equal to the less of the MTU size, VTEM maximum data size for the next hop, or the value received on the route setup or the GDS variable. So that you'll be able to see if you run a trace. And then lastly, this node is one of the endpoints, so he's at the end of the connection. That's how he calculates his MTU size. Here's a few examples I took from our installation to show you what the MTU size. There you can see on this particular connection, 1464, that's the MTU size. And there's another display of an HPR connection. There's the MTU size. I'm nearing the end of my presentation with regard to what you need to look out for. TGP profiles, I mentioned this as well. You need to copy that into your VTEM list so you can actually control what transmission groups your connections use. Remember, there's different TGPs that you can use. Those are all the ones that come standard with the IBM supplied default. Enterprise Extender provides flexibility by enabling you to use multiple Vipers. So you can imagine in a big environment where you have multiple hosts and you want to have this complete failover, you can set it up with multiple Vipers so that if your primary is not available or you move your Viper elsewhere, automatically your Enterprise Extender connection will follow that particular connection. Something to remember, if you do make changes to your XCA, I'm sure all of you are aware of this, you can only update that using the variact update command. You can bring down your XCA. This is the last part of my presentation. I thought I'd just include some problem scenarios just to give you a feel for what kind of problems you might experience. Hopefully, if you go by the book and you follow some of the pointers inside of this presentation, you won't need to review this particular portion of my presentation. So let's say, for example, your problem you're experiencing right now, there's a line activation failure. What could be the cause of this? An incorrect TCP/IP stack name. You have to specify this when VTEM comes up. So if you have the incorrect stack name, that could be one of the problems that could cause this particular problem. You have an incorrect source Viper address, or the source Viper address was resolved from the host name specified in the host VTEM style option or on the XCA group definition. All things you need to bear in mind if this is the type of problem you're experiencing. So now you have an activation failure. This message group is issued when VTEM is not receiving responses to XID or Exchange ID requests during activation. It indicates that either the partner is not responding to the request or there are connectivity problems within the IP infrastructure. They could include IP connectivity has been lost inside your network, so there's a complete failure inside of your backbone. The UDP ports are not defined with consistent values across the network. The Enterprise Extender has not been enabled on the remote endpoint. You need to enable that so that you can actually talk to the guy on the other end. If the Enterprise Extender connection path traverses one or more firewalls, the firewall must allow, remember we spoke about, I showed you that trace route I did earlier in the presentation. If NAT is being used, you need to, in the EE connection path, adhere to the following rules below. Avoid NAT. Enterprise Extender does not support NAT. Some more solutions for your problem. When a one-to-one address translation function is performed, the name to address resolution mapping for this host name yields the incorrect NAT address. If the connection network is being used with NAT, you must use host name on the definition when defining your VRN. 6.2 sessions do not stay up over EE. This problem usually can indicate that there's a limited resource or there's somewhere along the path there's a failure. For predefined Enterprise Extender connections, use disconnect equals no. We spoke about that earlier in the presentation as well. And for EE-VRN based dynamic connections, use coding dynetype equals VN, model with disconnect equals no, or a delay value of 60 seconds plus, shall I say. There's one we spoke about as well, CICS LS6.users disconnect equals no, prevent CICS from terminating its session at the end of every transaction. So here we have an active Enterprise Extender connection that unexpectedly fails with these messages. I took this from our log, and here you can see there's a reason for the NRP is an XID or exchange failure or LDLC command timeout. Probable cause or something you need to check out, the E connection inactivation due to LDLC timeout. Enterprise Extender periodically tests this EE partner to verify IP connectivity and that the partner is still there. When the tests are unanswered, the Enterprise Extender connection ends with the messages above. Common causes are the partner unexpectedly ended, so there was a failure on the remote end. IP connectivity has been lost inside of your network, or hopefully you don't have OMP route problems, because then you're going to have to do some serious problem determination over there. Poor response when using PS retry. After each path switch, HPR resets its sending rate to the initial value, so the frequent path switch can lead to reduced throughput. Something to bear in mind as well, if you're using PS wait to equal or same route can lead to excessive number of path switches. So these are parameters you code inside of your your TCP/IP config. Bear that in mind as well. Poor HPR throughput over an enterprise extender with multipath enabled. If multipath is enabled on a TCP/IP stack, you could have these packets going out on different paths. Something to remember, that could be the cause of your poor response. High CPU utilization in a branch environment with lots of enterprise extended connections. Check your LDLC, keep a live reduction time. Check your live time enterprise extender port option. A new enterprise extended connection is established between you and a partner, but sessions cannot be established. The cause can be that the firewalls are not allowing UDP traffic through. Enterprise extended connection links terminate due to XID or LDLC timeout. Consider tuning the LDLC parameters. These are all problems I just thought I'd throw in there. Like I said to you, hopefully you don't have to go through these. I think this could be the last one. The RTP pipe fails to successfully path switch even though an alternate link is available. It could be due to a problem with the enterprise extended connection. An HPR pipe attempts to path switch but fails to connect with a message that no alternate routes are available. Ensure that your HPR path switch start option are all greater than the EE-link in-op time. Excessive path switch messages, so you're seeing this on your console all the time, flooding the system console because there's constant path switches occurring. You can enable the HPR path switch message to reduce that. That's the operand there in your VTAM startup. And I think this is the last one. Unable to determine the APPN cause name associated with the RTP PU name that unexpectedly inactivates. Enhance the HPR activation and deactivation messages by setting that HPR IT message start option. So that'll reduce those messages over there. So in conclusion, hopefully this has been a beneficial session for you. Enterprise Extender is relatively simple to implement once all the groundwork has been done. By that I mean you have APPN enabled in your data centers. Depending on what type of rollout you're going to decide on, if you go the DLUS function where we use Cisco SNA switching, it is fairly simple because it just looks like it looks like another switch connection inside of your SNA network. There's a few key areas to watch out as I discussed in this presentation. Hopefully you can take some of this and apply it in your environment. I would suggest plan and test prior to implementation. We were fortunate enough to have a test bed where we tested for almost 2 months before we actually rolled out. And in conclusion, it works very well. Thank you very much for your time, and if there's any questions, I'll field them now.